just a brief overview of what we're going to talk to today. We will talk a little bit about NFDI and NFDI for Chem, so you can see in what context the ELN has been developed. We'll then talk specifically about the Chemotion ELN and the repository integration, some first steps, how you can get towards using Chemotion, and then some other NFDI for Chem offers that may be of relevance to you. Okay, so for those who are not familiar, NFDI stands for the National Research Data Infrastructure for Germany. It was founded in 2018, and it's really a key part of the federal government and states digitalization strategy. And the main goal is to improve the way research data is managed in Germany, create the appropriate infrastructure that goes along with it, and also the tools, provide trainings, and accompany the cultural change. These are really important aspects. The way it works is that, in a way, the NFDI is kind of the umbrella organization, and then within the NFDI you have various consortia representing different scientific disciplines, not just the natural sciences where we as NFDI for Chem are, but you also have a broad range of sciences. So we have cultural sciences, NFDI for culture over here at the left. We have engineering sciences. With some consortia we collaborate on some topics more because we have common data types, for example, and with some consortia we collaborate less. So for example, with NFDI for CAP we obviously have a lot of overlap. They deal with a lot of process chemistry side of things, so we have a lot of common stakeholders. It's not like an organization was created and a bunch of people were hired to form this organization. It's more like that existing entities got together to form a consortium. Roughly, you can split it up into a couple of categories. We have the learned societies who are actively involved, the GDCH, the DPHG, and the DBG. We have people from research data infrastructure, such as the KIT, where Chemotion was developed. And then we are closely advised by advisory boards from industry and publishers. But most importantly, we have the academic community. So here you can see is a map of NFDI for Chem partners, and it really is a broad national effort, and it's really exciting to be part of this broad national effort where so many people are involved from such a diverse range of backgrounds. We are not just active nationally, but also internationally, because these problems we are talking about with respect to research data management are not just relevant to Germany, they're relevant internationally. So with this respect, we are involved in various international entities, especially IUPAC, but also other organizations such as the RDA, the OSC, and GoFair. So why do we do what we do? So here's an analogy we like to show, and apologies to those who have seen this already. Here is a lab notebook from an unknown chemist from the Kaiser Wilhelm Society from 1927. Let's fast forward about 60 years into the future to the Cray 2. The Cray 2 was a supercomputer at the time. It was pretty big. You couldn't really fit it in a standard sized bedroom. It was prohibitively expensive, so the average person would certainly not be able to afford it. Only 30 years later, you have the smartphone that came about. It absolutely dwarfs the supercomputer in terms of processing power, in terms of size, and in terms of price. So pretty much everyone has a smartphone nowadays, and it's much faster than the supercomputer from back then. Let's have a look at a typical lab notebook from today. This is again another synthetic chemistry lab notebook, and as you can see, not much has changed really. The paper is whiter, yes, the handwriting is neater, but the real essence of how the research data is recorded is still very much analog in a very manual way. Right? And I have to stress here that this is the case for academia. In industry, this may not be the case. So what types of data do we actually deal with? So NFDI for Chem focuses on data driven by molecules. So these can be molecular properties, how the molecules were made in the first place, reaction descriptions, what were the conditions of the reactions, and again in a digital context. So how do we actually make this digital and machine readable? any spectral properties the molecules might have. So these can be NMR spectra, mass spectra, and then of course any biological activity thereof the molecules might have. So what's the status quo with these types of data? Well, as we already mentioned, a lot of it is very analog. You have paper lab notebooks. Yes, you have some digital data, either on some hard drives flying about. You have digital data that does come from machines and that then ends up in some kind of servers. But the worst way is actually how we publish this data. We take this once beautiful digital information, often machine readable, and then we destroy all the machine readable ability by making a JPEG out of it and dumping it into a supporting information document. And we call this process unfair. So FAIR is an acronym for findable, accessible, interoperable, reusable. So findable could be is that you can find data via a DOI unambiguously, accessible that the data set lives in a repository where it can be accessed, interoperable that the data is not in some kind of proprietary format that can only be opened by a program that you pay a lot of money for, and reusable that the reuse of the data is clearly defined. And this is where we really have to stress the difference between fair and open, right? You can have fair data that is open, you can have open data that is fair, but you can also have fair data that is not open, right? So for example, you can have the fair data set where the reuse of it is clearly restricted to a specific subset of people, right? And what we are interested first and foremost is data being fair. Open comes second. Of course, we are a big fan of open data, but most important to us is that you guys work fairly. So how do you actually get from the status quo to something that is reasonably fair? The reality is it's very hard to work fair retrospectively. So if we take again the example from a synthetic chemistry point of view, if you take the existing workflow and try to make data fair retrospectively, it's incredibly time consuming because you have to do a lot of things manually. You have to assign metadata manually. You have to convert file formats manually. You have to structure and organize things. You have to upload things individually, and it's incredibly time consuming. And you guys are already very busy working in the lab. You don't need to waste any more time than you already do. So the only realistic solution here is actually to work digitally right from the beginning, right? And this is where electronic lab notebooks come in, because ELNs can do a lot of the work for you to work fairly, so you don't have to do it manually every time. So this can be making sure the metadata is structured, keeping track of the file formats. So this is where ELNs come in. So what is our strategy to kind of help you guys work fairer? This is a brief sketch overview of the things that we're involved in. You can roughly split it into 3 parts. At the top is the interface with you, the academic community. So we have help desk and support systems. We have knowledge bases where you guys can look up various concepts. We provide teaching and training opportunities, and then enable you also to search not only RDM knowledge, but also data sets. In the center, you have the so-called, where the data is produced, the smart lab generating data that then feed into repositories or archives. And at the bottom, there's the kind of the stuff that goes on in the background. Standards need to be defined. There are legal aspects and policies that need to be considered, and terminologies need to be set as well to make things machine readable. So today our focus is on the central part because we're talking about ELNs. And the challenge here is really, how do you make it as straightforward as possible to use an ELN to get to fair data without costing you guys any more time? So let's have a brief look at some advantages of an ELN. So first and foremost, an ELN is a documentation tool. So it links experimental data to experimental descriptions. So the classic case at the moment is you have a paper lab notebook with an experiment code, and the data set will then be on the server somewhere. If you want to find your data, first have to find the paper lab notebook to find the experiment code, then you go to the server. So these things are not linked in a digital sense. And in ELN, the experimental data is linked to the experimental description, and there's none of this manual searching that has to be done. Of course, your data is a bit more secure. It's hard to lose an ELN on the back of a bus. Things are standardized, right? Not just the way data is collected, the way stuff is documented, including the metadata. It also means that you can within a working group, things are more standardized and you can actually understand another person's lab notebook, right? Because everything is set to another standard. Knowledge is findable, right? This is really the key thing, right? It's a lot easier to find predecessors' knowledge in the ELN. I think we've all been through the case where we've had to find predecessors' lab notebooks. The boss might have said, it's in this room, and then you go in the room and it's okay, which bookshelf is it on, which shelf is it on, which book is it, which page, and then by the time you've actually found the experiment, you may have invested a whole day, and even then there's no guarantee that you would be successful. So it really makes things a bit more straightforward if people want to replicate or reuse your data. And the most important aspect is that ELNs really help you to structure your data and experiments in such a way so that you can make the publication aspect of the data and the experiments as simple as possible. Of course, there's the question, what ELN should you use? And the answer is there's not one ELN that covers all subdisciplines. There's not one ELN that covers all research groups requirements. It really depends on many things. What are the costs? Where's the data hosted? How's it accessed? Who looks after it? Do we have money to look after this? And there are really very many good options out there. Today we're going to talk about Chemotion, but Chemotion may not be the right ELN for you. If it's not the right ELN for you, there's a fantastic tool called the ELN Finder where you can that might be able to help you to find other ELNs, so please do check that out. But again, we're going to talk about Chemotion today. So what makes Chemotion unique? So Chemotion is actually a holistic solution to research data management in that it covers the whole research data lifecycle. Many ELNs kind of end at the analysis point of view and kind of stop at the disclosure and publication point of view. So what do I mean here? That the ELNs will be very good at documenting and structuring all the data within an organization, but when it comes to actually publishing the data and the experiments in a repository, that step is a bit more cumbersome. And this is where Chemotion has a solution where it's actually integrated directly into repositories, so the transfer of experiments to the repository is seamless. Some quick facts to Chemotion. It was developed by researchers at KIT in Karlsruhe in collaboration with people from NFDI for Chem. It's an ELN that was specifically designed for chemistry and related disciplines, although it's now been expanded to other scientific disciplines. I'll be talking a little bit about more that later. And its main focus really is the realization of the fair data principles, right? And this is which makes it unique in the academic context, because fair data is something that is being pushed more and more in academia. It's open source and it's free, so therefore you don't have to pay any money for it. It's browser-based, and you can do various things with it. And the key thing is that it takes a lot of takes care of a lot of the fairness of your data automatically, so you don't have to. This is a rough scheme of how Chemotion works. It's usually installed on a server or virtual machine, which is then linked to an appropriate backup strategy, such as an institutional server. It can be linked directly to analytical devices, so you can ingest data from those devices. You can even convert the proprietary formats to open formats, and you can even control these devices via B and C clients. The users then access the ELN via any type of device. It can be their phone, a tablet, or a PC, so they can plan, document their experiments, and they even do data analysis in it. Up until then, everything lives on your server. Right, it's no more public than the NMR data that you have in your servers anyway. But if you do want to publish your data, there is a direct integration to repositories such as the Chemotion repository and Radar for Chem. So this is the basic view of Chemotion. You kind of have, let's say, large navigation from the left, medium navigation, and then details on the right. We'll go through each element of the ELN bit by bit. So at the left, we have the so-called collections. Collections are a hierarchical way of structuring your experiments and data. So it's very analogous to a folder structure. You have large folders with subfolders and subfolders. And by default, these collections are only seen by the creator of the experiments and data. So if you have a Chemotion instance where many people are involved in, only the person who creates these collections can see them first, but it is possible to share collections within a Chemotion instance. So you can say, hey, have a one-time look at my collection here, or you can even synchronize collections so people can have shared collections where they are synchronized between each other. You have a search function in the ELN, and the search function is quite neat. You can search reactions by name, by its reaction status, was it successful or not. You can search according to Inchi and Smiles, and you can also do a substructure search. In the middle pane, you have the so-called elements. Right? So what are the elements? So you have an elements for samples, so these can be molecules and properties of the chemical compounds. You have an element for documenting reactions, right? Doing your reactions in there. You have an element for well plates, screens, which gives a good overview of multiple well plates, for example, and then a more flexible element called the research plan. And we'll be looking at some of these elements in more detail now. Samples. So this is the overview that you have for samples. You can enter various things. You can give it names. You can give it an external label. You can say what the amount is. And you have your chemical identifiers, Smiles, Inchi, Morphol, Cas. And the neat thing here is not every molecule can actually be represented in a machine readable way. There are some limitations. So some inorganics, it is impossible to represent in a machine readable way with a Smiles or an Inchi code. You can select the so-called decoupled sampled mode, and there you can basically decouple the structure from the sample, so you can then still have a sample that is a huge polymer, for example, and still use that in your subsequent reactions. Samples can be connected to other databases. By default, PubChem is connected, right? So if you click on a sample and you see the PubChem sign, you can click on that and you get taken directly to the PubChem page, and you can also integrate SciFinder if that's set up. But that's an additional step that you have to set up. Okay. Reactions, this is where the main business end of synthetic chemistry takes place. This is kind of the rough overview. You have a scheme here, and this scheme is actually generated by things here below, right? So here you can see a stoichiometry table. These molecules are just dragged and dropped into the stoichiometry table, so you don't have to draw the molecules directly. If you have a sample, you just drag and drop it into the reaction, and then it appears. And this reaction scheme is actually populated by everything that's below. In the stoichiometry table, similar to other things that you might be used to from ChemDraw, if you change one thing, the other things auto update. If you have a very large molecule, you can toggle it, so just the name appears. You have this button called T, which stands for theoretical amount or actual amount. So let's say you're doing a reaction with cesium hydroxide and you have to add 3 milligrams of cesium hydroxide. No one will be able to ever add exactly 3 milligrams of cesium hydroxide. It's so hygroscopic, so you can then also record the actual amounts that you added, and the ELN will then make its calculations based on the actual amounts. There are other things you can document, so you can indicate its status. That is really quite a neat function. So when I've looked for through predecessors' lab notebooks, sometimes I found entries where someone had planned an experiment, but they never actually did it. But there's no way of actually knowing this, right? So here you can actually indicate what the status of the experiment is. It's very useful if you're working on a collaborative project. Start and stop times. I should say that these things can be added retrospectively, so there isn't an audit trail. So if you are working in a GXP environment and you do require an audit trail, then unfortunately this would not be the right ELN for you because it does not have an audit trail. You can then have experimental descriptions, and the neat thing here is that you can actually preset specific descriptions. So if you clicked on one of these buttons, a predefined text would be spit out, so you don't have to rewrite everything immediately. So that's one of the neat features. Analyses in Chemotion. In principle, you can keep track of any analyses in Chemotion. You can upload any file type. So this is what it looks like. If you want to add a new analysis, you can fill out a bunch of things. There's an upload box here. So for reasonably sized data sets, you can upload it directly to the ELN, so that if you then retrospectively wanted to have a look at analyses, you could then access them directly. Or if you have a very huge data set, then of course you could just link the file path to your institutional server, for example. Again, in principle, all data types can be uploaded to Chemotion, but specific data types, Chemotion can actually, you can actually do the analysis in Chemotion, and it can, for some data types, it can actually convert it to the open formats as well. Yeah, so the classic cases where you can do analyses are NMR, IR, mass spec. You can do that with ChemSpectra or NMRium, and these are both open source tools and integrated. So this is what ChemSpectra looks like. This is not just a picture. This is an interactive spectra editor, so you can do your integration and your picking in there. But again, you don't have to. You can still use a secondary program such as Mestranova, for example, and then just transfer your results back to the ELN. But this is actually quite useful, for example, in teaching labs, because it means the students can do everything in a single window. They plan their experiment, they document the experiment, they analyze the experiment, and they can even create a report for the experiment, all in the same ELN. And this makes it especially easy also for those running the teaching labs. It's a huge time saver. So what can ChemSpectra do? It can do 1H, 13C, 19F. It can do IR, UV, vis, and mass spec. HPLCs are in development. This is what NMRium looks like. NMRium has more sophisticated NMR analysis tools compared to ChemSpectra. Okay. There's a tab called QC and curation, which is very useful to keep track of what analyses you actually have. So if you are publishing a paper and you want to make sure you have all the analyses for your paper, there's kind of a traffic light system saying, okay, there is some data here, right? It does a very basic quality control. For example, counting protons. If it's expecting 15 protons from the structure, and you have 15 protons, it will say yes, it's a green light. But if it violates that, then it gives you a red light. Of course, you can't trust that quality control to 100%, but it can give you a quick indication if something is missing. Right? So only because there's a green light doesn't mean that you should just say yes, this is all perfect. You still have to do your usual checks. It just helps you identify things that are missing a lot easier. You can generate reports. So if let's say you want to write a supporting information for a couple of reactions, all it is you go to your reactions overview. You would then check the reactions you want to create a report for. You would click on the report generating button. There you can then select a template. So in this case, supporting information was selected. There you have various options. You could various things you can configure. You could order the reactions according to whatever order you want them. You can even do the numbering directly in the ELN. And then you can generate a report. The report is a .x document, and this is all being generated by the ELN. These structures are ChemDraw files, so you can edit them retrospectively. There are various templates that can be selected. Do we have templates for every journal? No, but it's certainly quicker to edit the output of this supporting information than it is to create one entirely from scratch. And the neat thing here is that it really eliminates a lot of human sources of error. So if you are compiling and supporting information manually, it's inevitable that you will have some copy and paste errors in there sooner or later. So this is one way of reducing the amount of errors, while even entirely eliminating the amount of errors you have introduced via copy and paste. You can also use report templates to generate spectra. So very often in supporting information, you have to append spectra as well. So you can then also do that with the report templates as well. Research plan. This is a more flexible element where you can document overarching thoughts or things that are not entirely of a synthetic nature, where you just want to quickly click some things together. There are various options. You can add text fields, you can add tables, you can add molecular structures, you can add samples or reactions, you can have pictures, so it can be pretty much anything you want. This is something that somebody clicks together. There are various export functions to docx, ODT, HTML, Markdown, LaTeX. You can even have an OnlyOffice integration. So if you have OnlyOffice, you can then integrate that and, for example, upload Excel files to that, and then actually do the editing of the Excel files in the ELN without having to download them and upload them all the time. So this is a good transition to the generic elements. Of course, not every chemist is a synthetic chemist, and our goal is to make the ELN as interdisciplinary as possible, and this is where the generic elements come in, or LabIMotion. So LabIMotion is kind of the name for the extension to the Chemotion ELN, where you can cover non-synthetic workflows. So you can see here on the right, this was a generic element somebody created, and as you can see, it's of a non-synthetic nature. And these things can really be customized manually. You can add checkboxes, you can have drop downs, you can add upload fields. This really can be created according to your requirements. And the really neat thing is that you can also have clear definition of workflows, right? So if you have a workflow that has to follow a specific procedure because it follows an SOP, for example, then you can define a workflow where it is only possible to go through a predefined way, or even multiple predefined ways. So how would that look like, for example? So here you can see a pre-screen recording. One would select what the next step is. So if you select cutting, then the next element would appear, where you could then enter various things. Or if you selected the other thing, another window would appear, right? So you can have predefined steps through a workflow. So you can really cover things of a non-synthetic nature that you might need here. You might not only want to have a new element, you might just want to have an additional tab. So let's say, for example, you are in this case somebody working with catalysts. You could then add an additional tab called catalyst synthesis, where you could have a predefined generic segment in there. Or if you are a photochemist, you could create your own segment where the details of the photochemical reaction are documented, right? So again, if you are synthetic chemists and there are just some things that are not quite represented within the ELN, you have the tools to create that and document it. What's coming soon is the so-called template hub, because obviously it can be a bit frustrating for people to create these templates all from scratch. So what we are enabling in the Chemotion repository is that people can actually upload their generic elements and segments and analyses to the Chemotion repository, so other people can have a look at what workflows other people have created, right? So you don't need to reinvent the wheel, and you can base your work on what other people have done as well. And we really hope this community process will then build a broad library of templates that other people can use. So the idea is that you can then synchronize templates from the repository, and then also this enables you to then also publish these additional aspects from the generic segments in your samples and reactions. Okay, so sharing and publishing in Chemotion. So within a single instance, collections can be shared or synchronized, right? I already mentioned that briefly. If you want to share data outside of your Chemotion instance, there's an easy way of doing that. You would just export a collection. This would be a zip folder, and then another person using a Chemotion instance just has to import the zip folder, and then they've got the entire collection there. When it comes to having multiple users on a Chemotion instance and also having Chemotion in a research group, it's very important to consider sharing rights, synchronizing rights, access rights within a working group, right? For example, if you have a bachelor student, you want to avoid it that they have the rights to delete every entry in a shared collection, for example. So you don't have to reinvent the wheel here. We have published some guidelines on how this could be implemented. Of course, this may not fit one-to-one to your research group, but it's a starting point, so you don't have to reinvent the wheel. And it's basically a traffic light system of it's a traffic light system of access rights. So this it can be who can read it, who can share it, who can download stuff, who can delete stuff, who can move stuff, and this can also be quite important. For example, so we had a request the other day: how do I make my experiments available in case there's an emergency, right? So you might want to consider setting up a system where students share their experiments with an emergency account. So if there is a medical emergency and the person cannot say what they worked with, you could then still access the experiment. So these are things to consider. So please feel free to read the paper and have a look at it. If you want to publish your data, you can publish it in the Chemotion repository. Let's have a quick look at the repository. So this is just the normal interface of the repository. You can have a look at how the reactions were done, and you can actually then download the data sets as they were published. And so if you want to do an overlay of the NMR, you can do that. The data sets, the entire data sets get DOIs, right? So a reaction will get a DOI, but then also individual analyses get DOIs as well. So you can reference these in your supporting information. If you download one of these data sets, you can see it's really as it was received. So here is actually the raw data that's suddenly published. So this really makes the reuse very straightforward. If you want to publish data, right, you could do it via the ELN gate, for example. It's kind of an ELN-like interface in the Chemotion repository, which makes the publication process a bit more straightforward. But the really neat thing here is actually that you can actually have a look through existing published reactions in the Chemotion repository or samples and actually interact with them as if they were in your own ELN. So here, in this case, analysis was open. So you wouldn't even have to download the NMR spectrum. You could have a direct look at the NMR spectrum in the Chemotion repository. Okay, so how do you actually get started with Chemotion? So the first point of contact would be our help desk. And then usually what we do is we do a free online demo of the ELN, so a bit longer what I've just done now with screen sharing. Then we'd have some Q&A, usually that's about 90 minutes. If you're then interested in further evaluating the ELN, we can provide a test instance free of charge, usually for about 2 months, but again, this can be extended as well if needed. If then after testing the ELN, you say, yes, we want to go ahead and have our own installation, we can provide free technical support to help you install the ELN at your institution. And then once you're in the production phase and you're using it, we also provide free continuous technical user support, including trainings and workshops. There's an online handbook where you can look up various how-tos, not just for admins, but also for users. There are also some videos there explaining various concepts. There's a YouTube channel with introductory videos to various elements of the ELN. They're available in both German and English. There's a hands-on workshop that takes place regularly online, which is kind of a learning by doing approach to learn stuff about the ELN. But upon request, we can also come to your institution and do a workshop for your institution. We require about 15 participants. And here, this workshop can also be extended to 2 days. And on the second day, we will focus more on the generic elements of the Chemotion. We have regular Q&A sessions that take place once a month. And the idea is here that you tell us your questions in advance, or you don't have to tell us in advance. You can turn up to the Q&A session and ask experienced users how to do specific things. And the next one would be on the 25th of May. The help desk I already mentioned, but you can also contact the help desk for other non-ELN related things. I'm struggling with NetDMP, for example, or I have a question about fair data. Other NFDI for Chem services that might be useful to you. We have our chemistry data days on the 6th of June. It's free, excluding travel and accommodation, and we really want to reach out here to the chemical community, how they can learn to manage their data. Various ELN providers will be there. And you can also hear from invited speakers how they have managed their data in a fair way. And this event is in the cooperation with the GDCH, the VAA, and the JCF, who will also be hosting sessions of career entry and also be doing a workshop on how to write a paper. So this is the rough schedule. So as you can see, we have an ELN session where ELN FDW will be there. They also have booths there, so you can actually talk to them directly. Information will be there, logs will be there, Chemotion will also be there. I already briefly mentioned the career entry workshop by the GDCH. Yeah. What else do we have? We have a knowledge base. So the knowledge base is kind of like a Wikipedia for research data management, but focused specifically on chemistry. And here you can look up various concepts of various depths. So there's some very easy things such as what are the fair data principles, but also some more in-depth articles such as how do I choose which repository for which data type. Teaching and training, we have a NFDI for Chem YouTube channel as well, where various more general RDM concepts are explained, so feel free to check that out. We have RDM workshops for chemists. They take place 1 or 2 days. They can be online or in person. Upon request, these workshops can be 2 days at your institution. So if you're interested in a general introduction to research data management, please get in touch. And these are kind of the topics that are talked about in these workshops. So what are the real basics of RDM? What are the basics of data quality and documentation? What is metadata? What are standards? What is controlled vocabulary? What is INFI? What is SMILES? Simple things as what is the difference between a backup and an archive. These things are not taught at undergraduate level yet, unfortunately, and until they are, this workshop is kind of meant to plug that gap so you have the opportunity to learn these key skills. Follow us and keep in touch. We have the usual suspects on social media, Twitter and LinkedIn. Actually, we have Instagram now. I need to add that to the slide. And we have a newsletter as well, which is released every 3 months. And last but not least, I think I'm bang on time. Thank you for listening.